Hi, I'm Bob Tabor with www.learnvisualstudio.net. I'm going to let you in on a little secret. Nobody memorizes all this stuff, at least not at first. It would probably take you several months of working and building applications in order to really internalize a lot of this. IntelliSense is just awesome, and it really helps you through a lot of the rough spots. Little code snippets online are great. I use cheat sheets, which allow me to, they're just basically notes that I've gathered from watching a video series or from reading articles online. It helps me to organize the information, see it visually, and then organize it in my mind as well. We're going to use this as a form of review throughout the series of lessons. This is what I promote on LearnVisualStudio.net, and it's a great way to index into the content to remind yourself of what the major ideas were, the crux of those videos. You can always remove the stuff you don't need. You can add stuff that you might think might be helpful in the future to make this your own. Now, I'm going to copy and paste from some notes. I used to type all this in by hand, but admittedly it was a very slow and painful process for both the teacher and for the learner. So you can see here that I've created on my desktop a little cheat sheet. I would encourage you to do the same thing, uwp-cheat-sheet.txt. You can call it anything you want. You can put it anywhere you want to put it. This is just the way I'm going to do it in this series. And I'm going to begin to just type in or copy paste things in here. And you should feel free to do the same. You can use mine or you can type it in yourself. I would recommend you type it in. Creates a little muscle memory. But at any rate, we're going to create a cheat sheet, and I'm going to paste in the big idea from a lot of the lessons. As we got started, there wasn't a whole lot that we could add that would be useful long term because it was a lot of high level ideas. But when we got into XAML itself in lesson number 4, we talked about the nature of the XAML syntax, how it is just a flavor of XML, or rather uses XML as to implement the syntax. And when you're writing XAML, you're really behind the scenes creating instances of classes and setting attributes or setting properties of those class instances that define the user interface. And, it's very natural for us to use an XML style syntax, especially if you're coming from a web development background. You're already using HTML to lay out your pages. Same idea here. You get designer support as a result of that. It's a much more succinct language. We compared writing XAML by hand versus writing C# by hand that essentially did the same thing, and we saved a lot of keystrokes and characters. Also the XAML parser was very intelligent, and Visual Studio played along, and it allowed us to write code much more succinctly to define our user interface. All right, moving on from there, in the next lesson after that, we talked about some specifics of XAML, and we talked about type converters, and we said that this is one of the ways in which it's made easier to write the XAML than it is the C# version, because we can give attributes of elements, literal strings in XAML that are converted into enumerations or potentially even instances of classes in C#. So type converters, one of the items, one of the tools that would help us keep our code succinct. We then talked about several different topics related to XAML in the next lesson, understanding default properties, complex properties, and the property element syntax. So you can see here that the default property for a button is the content property. We set the button's content property to click me. We could have done the same thing by just setting that attribute inside, but by understanding default properties, that kind of led us to the next step in the process, which was to talk about complex properties. So I've got kind of a big chunk of code here. I'm going to paste it in. Unfortunately, let's turn off word wrap for just a moment here so you can see this. We have a button, and we're setting the background of the button in a complex property, setting its property, the background property, using the property dot element syntax. All right. And remember, in this example, there was a lot more going on, but it was hidden from us by Visual Studio and the XAML parser, because a lot of that could be inferred by the context of what we typed in between the elements that we had here in this particular complex property. All right, the next up we talked about the XAML schemas and namespace declarations, and we said that stuff at the very top of the page, don't touch it. We also said that the schemas are part of XML, and XAML is no different. It has a number of different schemas. I think we saw like 5 or 6 different ones, and they define the rules for the XAML syntax itself, for the controls that are defined in the Universal Windows Platform API. They're used for designer support by Blend and Visual Studio and so on. And then the little namespaces that were created, the little whatever it was, some value and then a colon, they tell the XAML parser where to find the definition, or rather the rules for a given element in the XAML. Now, a lot of the XAML that we write will have no namespace little prefix in front of it, because a lot of it's defined in the default namespace for our page. Moving on, we talked about layout, specifically about layout grids with grids, but let's start with just talking about layout in general. The layout controls don't have a content property like a lot of the other controls have. Instead, they have a children property of type UI element collection. This allows us to add multiple items into a single layout control. And we saw what happened whenever you attempt to put multiple controls inside of a control, inside of the content property of a control. You get that little error that you're trying to set the content property more than once, and it won't let you do that. So by embedding any control inside of a layout control, inside of its elements, you are implicitly calling the add method of the children collection property for that given element. So the grid.children.add my button, right? All right, and then let me give you a quick definition of a grid. I just copied this from one of our examples. Here you can see that we've defined both rows and columns using property element syntax. Whoops, let me get rid of that one. How that got in there. Much better. Okay. So we have row definitions, and then we define a number of rows. This is all out of whack. Okay, there we go. And notice that we set the heights and the widths as well, which the sizes can be expressed in a number of different ways. And so let me paste that in here. So let's turn WordWrap back on. Down here. Okay, so it can be expressed in terms of explicit pixel sizes, right? So I can set it so equal to like a 100, for example. All right, but we said that that was a bad idea because we're working with different form factors, even within a given device family, and it may not look correct on a given form factor. So we would prefer to use auto and star sizing, which are relative ways of expressing sizes. Auto will use the largest value of the element it contains in order to define either the width or the height of that given row or column, respectively. Or we can use star sizing, which says utilize all the available space that we have. So we also saw an example where we were able to prefix the star with a number. And so, for example, we saw how one star would essentially be saying, of all the space available, give me 1 share of the total. Whereas 3 star would say, hey, give me of all the available space, give me 3 shares. So essentially in this example that I created right here, there would be 6 total shares, and a 3 star would be essentially either 50% of the width or the height, depending on what we were defining. We also talked about how elements will put themselves inside of the grid at a specific row, column, or a specific cell. And we use this attached property syntax. Remember that grid.row is not defined in the button, it's actually defined in the grid control, but we can attach it and say, hey, I want to set myself to this row and this column. So that's how we will actually work with the grid control and define where we want to put ourselves, to put our controls. Also notice that whenever we're referencing rows and columns that it's 0 base, so by setting the row equals 0, we're saying first row, 1 would be the second row, and so on. Same thing with columns. Now, there's always one default implicit cell. There's always in every grid a row 0, column 0, even if we don't define it explicitly, okay? And so if we don't specify that whenever we're working with a given object that we're trying to place inside of a cell, that it will be in the default cell, so, or the default row or the default column. So in this case, we're saying set the row equal to 0, first row. We could have left that off completely and it would have been the same thing. Also, by not defining the grid.column, we're essentially saying grid.column equals 0 because we're saying put it in the default cell. All right. All right, that's all we said about the stack panel, about the grid. We moved on and talked about the stack panel. Here's a simple definition of a stack panel. We can also set various properties of the stack panel, and we talked about the vertical orientation is the default. So from top to bottom, the first text block will be at the top. The below it vertically will be the next text block. We can change that to a left to right flow if we were to set the orientation to horizontal. That should be alignment should be orientation. Okay. Most layouts will combine multiple layout controls in order to get the desired effect, and you'll see that as we build real examples throughout the remainder of the series. And then we also said the fundamental difference between a grid and a stack panel is that grids will allow you to overlap controls. So if you put 3 controls in the same cell and you set the top and the vertical alignment to top and the horizontal alignment to left, they will essentially stack on top of each other. And you may not be able to see items below or underneath other elements in the same cell. However, stack panel will always stack things on top of each other or horizontally left to right. Okay. So that's all I have for this review. Let's pick it up with a little exercise that will hopefully get you working and get these concepts under your belt. We'll see you in the next lesson. Thank you.